What if we could build gigantic power stations in space by 2030, beaming endless energy straight to Earth? No clouds, no nights, no interruptions, just constant clean power. Could humanity finally escape fossil fuels and tap the sun from above? Let's explore this future. Chapter 1. The Science of Space Solar Power. Think of capturing the sun's energy in space, where it shines non-stop, day and night, never blocked by clouds or storms. This is the vision of space-based solar power, or SBSP. Unlike earthbound solar panels, which only work when sunlight hits them, SBSP could produce electricity 24 hours a day. In orbit, massive solar arrays soak up sunlight continuously, convert it into electricity, and beam it down to Earth via microwaves or lasers. Ground-based receiver stations capture this energy and turn it into usable power. Think of it as a giant wireless solar farm floating above our planet. NASA has analyzed SBSP's feasibility, exploring cost, efficiency, and environmental impact. Their research suggests that with advancements in solar technology, wireless power transmission, and space construction, functional space solar stations could realistically be built within the next decade. The potential? Endless clean energy streaming straight from the skies. Chapter 2. The Race to Orbit. By 2024, SBSP technology was taking serious strides. Caltech's Space Solar Power Demonstrator, SSPD-1, successfully tested wireless power transmission in orbit, showing that enormous solar panels could unfold and beam energy back to Earth. At the same time, NASA partnered with companies like Ascent Solar to develop ultralight, flexible panels. Traditional rigid panels are heavy and costly to launch, but these foldable designs can be packed efficiently, launched, and deployed like space origami. Meanwhile, Europe's Solaris project aims to launch a 1-megawatt orbital solar plant by 2030, a small but critical step toward large-scale energy from space. Together, these efforts signal the beginning of a global race to orbit, where nations and private companies compete to master continuous, clean sunlight from above. Chapter 3. The 2030 Vision. Looking ahead to 2030, the vision for SBSP is ambitious but tangible. Engineers are designing a 30-megawatt space solar plant capable of transmitting electricity down to Earth, enough to power thousands of homes without interruption. Europe is taking an even larger view. The ESA's Solaris initiative plans modular solar arrays in geostationary orbit, positioned so they remain fixed relative to Earth. These panels could eventually supply up to 10% of Europe's energy needs. Unlike terrestrial renewables, SBSP could provide continuous power, solving the problem of nighttime energy drops and weather-related fluctuations. Think of entire cities, powered seamlessly by sunlight, captured hundreds of kilometers above. By 2030, these installations might not just supplement our current energy supply. They could start reshaping how electricity is produced, stored, and distributed, ushering in a new era of reliable, renewable energy where fossil fuels take a back seat. Chapter 4. Global Collaborations. SBSP is not a solo endeavor. Countries around the world are racing toward this goal, combining expertise and resources to overcome enormous technical and financial challenges. Japan's Ohisama program is testing satellites equipped with photovoltaic panels designed specifically to capture and transmit solar energy. In the US, startups like Etherflux are exploring laser-based energy transmission, pushing the boundaries of what's technologically possible. These projects highlight the necessity of international collaboration. Launching massive arrays into orbit, safely transmitting energy across long distances, and scaling it to meet global demand requires knowledge and resources that no single nation can provide alone. By pooling innovation, countries and companies can overcome barriers faster, creating a roadmap to a future where continuous, clean energy from space is not just a concept, but an attainable reality for all. Chapter 5: The Future of Energy. If SBSP becomes operational by 2030, it could revolutionize our relationship with energy. Continuous solar power from space would reduce dependence on fossil fuels, lower greenhouse gas emissions, and provide electricity to remote or underserved regions. Think of nights when the lights never flicker and cities powered entirely by sunlight collected hundreds of kilometers above. Yet challenges remain. Costs are immense, technical hurdles are complex, and global regulations will need to evolve to manage orbiting power stations safely. Innovation, investment, and cooperation will be essential. But if humanity rises to the challenge, space-based solar power could become the ultimate energy solution, a constant, clean, and virtually limitless resource. A future where the sky itself is our power grid might sound like science fiction, but by 2030, it could be science fact. If you enjoyed this video, don't forget to like and subscribe for more mind-blowing what-if explorations.